So today's lesson is going to be all about significant figures, and we're going to talk about significant uncertainty. Just think about it, if you were to weigh a small rock on a scale and tried to measure it to the nearest whatever, you'd want to know exactly how that works. Well, today we're going to kind of define some of those rules to hopefully use that to discern our significant figures. Now, there's four basic rules that you're going to want to keep in mind when you go through identifying significant figures. And so let's talk about those rules briefly as we get started with some of these questions. First, all non-zero numbers are significant. Zeros between non-zeros are significant. Placeholding zeros at the beginning and the end of the number are not significant. And zeros at the end of the number are significant only if there is a decimal point present. So you have to have a decimal point to successfully be able to identify zero as a significant number. And so what we're going to go through is a series of examples where you have numbers that have zeros in various locations, and we're going to focus on the total number of significant figures, but I'm also going to try to take some time and identify the numbers that have both significant and non-significant zeros. So the first number we're going to go ahead and put on the board here we have is 102,505, and we want to really pay close attention to the zeros. Now, it should be understood that any number 1 through 9 is indeed going to be significant. So that leaves only pretty much those zeros. And so if we're recalling the rule of where any zero found between two significant numbers is significant, it makes these zeros that we've underlined significant. And so when you count those zeros, you end up with a total of 6 sig figs because you have the ones, the twos, the fives, and then you factor in those zeros, so that ends up being a total of 6 significant figures. However, you want to keep in mind that there are 2 significant zeros in there that contribute to that total number. Now, in this next number, we're going to look at another one of those rules, and here we have 65,980. And the only question is really about that zero found on the right-hand side. Now, it might be tempting to consider that zero significant, but it is not significant in this case. In fact, zeros found to the right of a number when there's no decimal point are not significant. And if you recall, any number that falls between 1 and 9 is going to be significant. So when we count them, we end up with the 6, 5, 9, and 8 actually being significant in this case. And so you want to be mindful of the placement of zeros, because we're going to do another example where we're going to have a mixed bag of both significant zeros and non-significant zeros. And so let's take a look at that. If there's a couple of rules that need to be recalled here. This decimal point is definitely going to be very important in terms of this number. And the first rule I think of is the rule of the decimal point, where the zeros found to the right of a non-zero digit number are going to be significant. Now, in this case, the zeros to the left are not, and so when you count them, you end up having 3, 2, 5, and 0 to ultimately have 4 significant figures. And it's important to note that those zeros on the left-hand side are not significant. So we want to keep that in mind as we go forward, and we're going to sample doing another question with another level of complexity, I suppose. And so with this number here, we're going to look at all of the zeros, and again, you kind of have another mixed bag scenario where you have zeros that are both significant and non-significant. Now, obviously, the zeros to the left of a non-zero digit number are not significant. But what is significant are going to be the zeros found sandwiched between the 2 and the 3, as well as the zero found to the right of the non-zero digit number. And when you add them all together, you end up with a grand total of 5 significant figures, keeping in mind that you have 2 of the zeros that are significant, and that makes a grand total of 5. Now, for emphasis, I want you to understand that sig figs is just an abbreviation for significant figures, and this serves as kind of a predecessor lesson when you're learning about significant figures.